Hey there, physics. So we've been working on calculating how much energy an object has. And today I have a little lab for us here. Today is called Superball Bounce. Probably got a digital copy of this. What we're going to do in this lab is we are going to bounce a bouncy ball. Here I have a ping pong ball. You could use a super ball, or you can use really kind of any bouncy ball you want. And I have a meter stick taped to the counter here. And we are going to bounce the ball, and we're going to measure how high it bounces up and kind of how much energy it loses in a bounce. Right. When we hold the ball up to this height, up to whatever height we choose, it's got some gravitational potential energy, right? When I drop the ball, its height gets lower, which means its potential energy gets lower, but as it's falling, its speed increases. And since its speed increases, its velocity increases, it's gaining kinetic energy. So that potential energy becomes kinetic energy. And then when it hits the ground, some of that energy is lost in, like, for example, making the sound. And some of the energy is lost in warming up the ground and warming up the ball just a little bit. We might not even be able to measure the temperature difference. And maybe a little bit of that energy is lost in deforming the ball a little bit. As the ball hits the ground, its shape will kind of squish maybe just a little bit before it gets shot back up. And so when it comes back up, it will not go back as high as it started. It will go less high. So what we're going to do is we're going to drop the ball. We're going to let it bounce, see how high it goes. Let it bounce twice, see how high it goes after the second bounce, and so forth, right? And we're going to calculate how much energy it loses. Okay, so the first step in this lab, if you look at your handout, it says choose a height to drop your ball from. And I'm going to drop my ball from 1 meter high. Nice, easy place to start. It says make sure your measurements in meters. So 1 meter. In fact, let's say 1.00 meters, because I'm going to drop it from right there. The second one, it says use a scale to measure the mass of your ball. So depending on your ball, I have a scale right over here. I'm going to measure the mass. You might not be able to see it on the camera. The mass of my ball, my ping pong ball, is 2.66 grams. And it says we're going to want that in kilograms, right? So 2.66 grams, if I divide by 1,000, I'll write it down here, is 0.00266 kilograms. If your ball weighs something different, just take its mass in grams and divide it by 1,000, and you'll have kilograms. So I'm going to record my initial height as 1.00 meters on number 1, and my mass as 0.00266 kilograms on number 2 there. Okay, number 3, it says then calculate the amount of potential energy the ball has before it's dropped. We'll do that math at the end here. Number 4, it says drop the ball and allow it to bounce 1 time and measure the height that it bounces to. Okay, you'll have to be ready to watch really closely as the ball bounces. Usually, maybe you'll like to do this with 2 people. One person drops it and the other person measures how high it bounces up to. I'm going to try to do it myself. I'm going to have to try a couple of times. You'll notice, I don't know if you can see it on the camera, but 0 on my meter stick is at the ground. So that when I'm looking at how high is it, it's telling me how high it is, right? And also keep in mind, I'm going to read from the metric side and not the inches side. So I'm going to put my ball up here, I'm going to drop it, and I'm going to see how high it bounces. And it looked like right about there. Let me try it again just for good measure here. Right about there. Okay, and right there, if I look on my meter stick, that's right about 70 centimeters. So it bounced up to about 70 centimeters. And of course, we want this in meters. So I'm going to divide 70 by, that's 70.0 right there. I'm going to divide by 1,000, or I'm sorry, I'm going to divide by 100 and put 0.700. So how high did it bounce? 0.700. And then number 5, calculate the amount of potential energy it has after 1 bounce. We'll get to that in a minute. Number 6, how much potential energy was lost in the first bounce, and we'll subtract when we get there, right? And let's go ahead and do that right now. So looking at number 3, how much potential energy the ball has before it's dropped. Keep in mind potential energy is mass times g times the height. So the potential energy is the mass, which was 0.00266 kilograms, times g, which is 9.81 meters per second squared, times the height, which was 1.00 meters, something like that. Now I'm going to take my trusty calculator and figure out how much is all that. 0.00266 times 9.81 times 1, of course, and I get 0. Let's see, I need 3 significant figures. 0.0261. And this potential energy is measured in joules. 0.0261 joules. Alright, number 5, calculate the amount of potential energy it has after one bounce. Okay, so again, potential energy is mass times g times height. And the mass doesn't change. It's 0.00266. G doesn't change. It's 9.81 meters per second squared. The only thing that changed is the height, and now the height was 70 centimeters, remember, which was 0.700. Okay, so let me figure that out with my calculator. 0.00266 times 9.81 times 0.700. And I got, let's see, 3 significant figures, 0.0183. And that's in joules, of course. Okay. Number 6 says how much potential energy was lost. So we'll just subtract. We'll take how much it started with, which we calculated on number 3, 0.0261. And we'll subtract what we got on number 5, 0.0183. And let me grab my calculator. And let's see how much was lost. 0.0078 joules. So my ball lost 0.0078 joules on that first bounce. Okay, number 7 says organize all the numbers that we've measured into this table here. Okay, so for the height, my original height was 1.00 meters, and the potential energy at that point was 0.0261 joules. After the first bounce, it was at 0.700 meters, and its energy, potential energy, was 0.0183 joules. And then it asks us to find the energy after that first bounce. We'll subtract. That's just what we did on number 6. So it lost 0.0078 joules. Okay, now we're going to go ahead and we're going to take some measurements to complete the table. So we're going to let it bounce 2 times and see what height it's at. And then we'll let it bounce 3 times and see what height it's at. So let's go take those measurements. So now let's let the ball bounce 2 times and see what height it ends up at. Okay, and this gets a little tricky because sometimes it doesn't always bounce straight back up. Sometimes it goes, bouncing off somewhere and you got to go chase it. So let's see how it goes here. So I'm going to put it right back up there at 1 meter. 1, 2, right about there. So that was right about 49 centimeters. So 49 centimeters, 0.490 meters. So after second bounce in my data table, 0.490 meters. Now we'll do 3 bounces. Okay, and this is the tricky one. So let's try this. 1, 2, 3. Right about there. So right about there, it's about 36.5 centimeters, so 0.365 meters. 0.365 meters. Okay. Now let's go back and let's calculate the potential energy for each of those. All right, so after the second bounce, it bounced up to 49 centimeters, 0.490 meters. Let's calculate the potential energy. So the mass of the ball doesn't change, right? So it's still the same mass. It's still 0.00266 kilograms. So 0.00266 kilograms. G doesn't change. It's still 9.81. And now the height is 0.490 meters. 0.490. And three significant figures. I've got 0.0128 joules. Okay, so now how much energy was lost? From the last one, after the first bounce, it was 0.0183, and now it's 0.0128. So let's subtract and see how much was lost. Okay, and that's 0.0055 joules was lost. Now let's do the after the third bounce. Okay, so now to figure out its potential energy, its mass was still the same, 0.00266. G is still 9.81, and now the height is 0.365. So now I calculate its potential energy as 0.0095, let's say. Okay. Now we'll subtract to figure out how much was lost. After the second bounce, it was 0.0128. After the third bounce, it's 0.0095. So we'll subtract those and see how much was lost. I got 0.0033 joules was lost. Okay, so question number 8. It says, did the ball lose the same amount of energy every time it bounced? And if you look at the numbers, after the first bounce, it lost 0.0078 joules, and then it lost 0.0055 joules, and then it lost 0.0033 joules. So no, it does not lose the same amount. It looks like it's losing less and less energy each time it bounces. And then number 9, if you were to drop the ball from a different starting height, would it lose the same amount of energy on the first bounce? Well, I don't think it would. I mean, consider if we had started at 70 centimeters, well then it's after its first bounce, I would expect it to lose 0.0055 joules, right? Because it would be like having started after the second bounce. So I would say no, it would not lose the same amount after the first bounce, because then the first bounce for that case would be like the second bounce for this case, if I'm making any sense there. So for number 9, I would say no, it would not lose the same amount of energy. All right, so there is the Superball Bounce Lab. Hopefully that helps us get a little bit closer to being able to calculate how much energy an object has.